So yesterday we were loading data to Snowflake and you're facing some issues with the storage integration. So now let us try to update the policy. So I'm trying that. 1 second. So open the role in which we have created that yesterday. This is the role I have created yesterday. So click on the trust relationships. I'm trying to edit the policy here. Let me edit it. I will give you this text, don't worry. So update policy. Fail to update trust policy. Invalid principle in policy. Let's see. This is from the Snowflake. This ARN is from the Snowflake. Let us see that ARN again. Okay, copy this. Let's again edit this policy. Let us also use service principle. Sorry, service. This is the same policy we have yesterday. I just copy pasted here. Let's update it. Okay, the policy is updated. Let's see if it works or not. Let's refresh our Snowflake account. So we are in the database and schema in which we want to create our external stage. Go to stage, click on Amazon S3, provide it as external stage. The path of that is, let's copy this path. I'm in the sample files now. Let's copy this S3 URI, paste it here. Let's provide the comments later. If it works, I'll provide that later. Let's try to view the SQL. Copy this and click on create. Still it is not authorized. This is very strange. Previously it used to work, but now what's happening? Okay, it was not on. Let's try to create another storage integration. 1 second. Let's create the role another storage integration. If it doesn't work, I'll figure out another way. Ideally, this should work. This has worked for so many batches. Okay, so let's quickly create another bucket. Log into this AWS. Go to S3. I'm creating it freshly. Maybe some issues with the configuration. Create a new bucket. Let's unblock this public access and acknowledge that I'm okay with that. Enable versioning and provide a name to the bucket. Snowflake S3 storage. Let's try this. Let's see what is there in the advanced settings. Okay, create bucket. Okay, and hyphens are not allowing. Let's try with underscores. Okay, underscores are also not being accepted. Okay, hi. Bucket names contain unique error, but bucket name must also contain and character valid bucket names are and hyphens are allowed. What's wrong with this? Snowflake. S3 data load. Let's try this. Must not contain upper name characters. Okay. Okay. So let's create it. This bucket name should be unique as we discussed yesterday, just like the Gmail IDs. This name should be unique. Let's create a folder here. Snowflake files. Into this folder, I'll be uploading the file. Sorry, not add folder. Add files. Let's add this sales file. Let us rename this file first. Later we are getting issues. Okay, let's rename this. Just remove the spaces. Okay. Let's upload this file. So upload it. Okay, now let's go to IAM roles. Let's create another IAM role to access this. Search for IAM. IAM stands for Identity and Access Management. So here click on the roles. Create a new role. Search for S3. Okay, let's use this option. Any option is fine. There is no restriction on that. Let's create it. Okay, sorry. Now we have to select the access level. S3 full access. Select this policy. Next. Here we have to provide the name of the role. Snowflake ETL role. Let's make it this. So this is the existing policy. So to this we just need to add the Snowflake ARN. That's all. Let's see. Let's create it. Okay, create this role. Now go to Snowflake and create a storage integration, new storage integration. So we are in the database and schema. Let's create. Okay, integration is not available. Let's go to the worksheets. Data loading. Okay, we have this. Let's copy this and make some changes. Okay, I'll name this as Snowflake S3 integration. Snowflake S3 integration. This is uppercase, lowercase, it doesn't matter. Anything works. Type is external stage. Provider is S3. Storage role ARN. Let's copy the ARN of this. Snowflake ETL role. So where is the ARN? Okay, this is the ARN. Let's copy paste this here. And then storage locations. Let's copy the S3 path. Okay, copy S3 URI and paste it here. Okay, this is the locations. Just create it now. Creating using account admin, yes. Where did it got created? Let's choose the database and scheme. Otherwise, it would have been created in the default ones. Let's rerun this. Okay, it's created. Let us describe this. Describe integration and the name of the integration. Okay, this is created. If you see here, this is the IAM role, and this is the one generated by the Snowflake. So this one we have to use it in IAM role. Let's go here, click on trust relationships, edit policy. Here we need to provide comma AWS. AWS within the double quotes is ARN. That's all. Let's update the policy. Now the policy is updated. Let us try to see if it is working or not. Now go to the database and schema in which we need to create this external stage. Okay, within this database and DE schema, create stage. The name of the stage is, let's make it external stage S3. The Snowflake URI. Let's copy this. This is not URL, this is URI. Uh, Copy this here. Comment is optional. Let's enable this. Set up the storage integration. This is the one we have created right now. Let's try to create this. So whatever we are doing, it is not allowing. Let's try with the credentials now. AWS access key and secret key. We have to generate these credentials. Let's see how we can create it. 1 second. Go to S3 account, S3 bucket. This is our bucket. Let's go to permission. Somewhere there will be the keys, secret keys, access control list. Let's edit this. Okay, let's go to, I think it would be in IAM. Go to IAM users. We don't have a user. Do we have any security credentials? Let's see if we have any credentials here. I think it all looks like NA. We don't have the keys here. We don't have it here. Okay. This is very strange. Why is it not working? One second. I am roles. Let us try give one more try with the role. I got an idea. Let's try this. Edit policy. Remove this service. Update policy. And let's try this one last time. Otherwise, we'll go with the other concepts. We'll see these two words and I'll try to figure out somehow. Hmm. Stage. External S3 stage. Let's go to the bucket. Copy S3 URI. Paste it here. Authentication. Let's try to create it. Okay, still it is not working. Error assuming the role is not authorized to perform on ETL. Okay, let's don't waste our time. Let's check the other concepts. Okay, let's see what else we have written here. Okay, there are types of cache. Let's discuss that. We'll try to complete these theoretical concepts. Types of cache. Cache means storing something on the memory, and whenever we are trying for the next time, it will be giving the results from the cache. Okay, so there are three types of cache in Snowflake. So the result cache, metadata cache, and local disk cache. Okay. There are three types. Result cache, local disk cache, remote disk cache, local disk cache, sorry, and remote cache, or we can also call this as query cache. Okay, remote disk cache or query cache. Let's see what each of it does. Okay, in the result cache, let's say if you have run some query now, so the results will be stored in the memory for the next 24 hours. Okay, the results will be stored in the memory for the next 24 hours. If we run the same query again, instead of executing that against the table, it will pick the results from the cache. Let's see. If we run the results will, let's write the results will be stored for next 24 hours. And if the query is running within 24 hours, provided no updates to the data, it will pick from cache. Okay, it will pick from the cache. It will not run the query again. Let's try to run some query from the tables whichever we did not query so far. Sorry. Let's go with the Snowflake sample data. You can take any of these tables. Copy the name. Select star from this customer table. I'll just see limit 10. Okay. So let's try to apply some logic on this. The customer name, address, phone number. Okay, marketing segment. Okay, I want to know for each marketing segment how many customers are there. So let's say customer marketing segment, comma, count of star. You know SQL. Whenever you are using aggregates, you should do group by C marketing segment. Okay, let's run this query. Okay, it has run in 162 milliseconds. Now I'll be running the same query again. Okay, now it has running 36 milliseconds. So let's try to run one more time. Now it is 31. So 31 or 36, there is no big difference. Now it is flickering around 30 to 40 milliseconds. Initially it was 161. So let us see the query history. Query history. Where is that? Okay, go to query history. Okay, this is the first time we have run. Where is that? 162 milliseconds. This is the query ID. Let's go here and see. Query profile. Okay, if you see here, it total partitions is 3. It has also scanned 3 partitions. And the percentage scanned from the cache is 7.25. Did we run this query earlier? No. This was the first time. Okay, here we have some metrics. Okay, let's try to go to the other query. Other query which has run in less than 162 milliseconds. Go to query profile here. See here, it did not scan anything. It has directly taken the result from the cache. See here, even the query says here, query result cache. So it has taken from the cache. So this is how, if the same query is running within the next 24 hours, it will not pick from the table, it will pick from the cache, provided that there are no updates to the data. But if there are some updates to the data, then it will again query the table. Okay, so that is about the result cache. Now coming to the local disk cache, it stores the data in the warehouse. Okay, so this is we are running this query on the compute warehouse. The data will be stored in this virtual warehouse. Okay, so the result will be picked from the cache if there are no changes to the data, provided that the warehouse is not suspended. Okay, we have implemented auto suspend and auto resume options, right? So if you suspend the warehouse, then the results will be gone. Otherwise, it will pick from the results from the warehouse cache, or we can say local disk cache. Mostly it is meant for uh, metadata. It will store the metadata. Okay, metadata means the information about the tables, like the minimum values, maximum values, how many columns are there, how many rows are there. That kind of information will be stored in the uh, local disk cache. Okay. So unless and until the warehouse suspends, the results will be retrieved from the warehouse. Results will be stored in the virtual warehouse, and it will pick from warehouse unless and until it is suspended. Okay. It will pick from the warehouse unless and until if the warehouse is suspended, then it will not pick the results. So how does it know uh, where it has to pick the data from? Is it from the result cache or the local disk cache? How does it know? Okay. So the order of preference is first it will look in the result cache. So if it doesn't found, if it did not find the data there, then it will go into the warehouse. Okay. So if that is also not found, then it will check in the last one. What is that? Remote disk. Okay. So now let us see what is this remote disk. Here the results are stored in cloud service layer. Results stored in cloud service layer. So we know the three layers of the Snowflake, right? Compute layer, data storage layer, and the cloud service layer. Here the results are stored in the cloud service layer. This is shared across the warehouses. This is shared across the warehouses. Okay, I mean, they'll be asking you what is cache in Snowflake and how does it help in improving the query. Okay, so this helps by storing the results in the memory, and whenever we are querying again, it will pick from the memory instead of rerunning it again. Okay, so we also have something called this remote disk cache. This is stored in the cloud service layer. Along with this, we also have a metadata cache. Okay, so metadata cache, how can we say that? Uh, it will just like the local disk. In the local disk, not only metadata, everything will be stored on the warehouse. But in case of metadata cache, it will store only the information related to metadata. Information related to metadata means information about the tables or the data. The table name, the number of columns, the number of rows, the minimum and the maximum values, all of that is available in the table. So without actually requiring a warehouse, this metadata cache doesn't require a warehouse. Okay, let's say I'll run a count of star from the table. Select count of star from, let's say, this table. Okay, I'll create a new worksheet. I want to show you how it runs without a warehouse. Okay, by default, the warehouse is getting selected. Okay, let's switch the role and see. Okay, for every role, we have the default warehouses, compute warehouse. Okay, here my intention is to say that this count of star or the minimum or the maximum of values doesn't require a warehouse. Let's run this. Okay, we have got 1,50,000. Let's go to the query history. Okay, let's open this. See here, it did not run any of the partitions or it did not scan anything, which means that it doesn't require a warehouse. This information is already stored somewhere. That somewhere is nothing but the metadata cache. Okay, so let me reiterate what I said. Result cache, it will store the results in the memory for next 24 hours. In the local disk cache, it will store the results in the disk, which means a warehouse. So not only metadata, it will store everything, all the data whichever we have queried on that particular warehouse. So this will be active unless and until this warehouse is suspended and there will be no data changes on the table. And coming to the remote disk, the results are stored in the cloud service layer. So in extension to this, we also have a metadata cache, which will store metadata information about the tables like the count, minimum, maximum, average. For running those queries, you don't need a warehouse. Okay, let's if you have seen with for this query, it has done some scanning of the partition, scanning of the data in the first run. So in the subsequent runs, it did not happen. That's a different story about the result cache. So now this count of star, or if we do minimum or maximum of something here, it doesn't require com compute. Let's try another query. So let's see what information is there. Let's do select star from this select star requires warehouse because this is a data computation. It is not stored anywhere. Okay, so let's see the minimum and maximum of the customer key. Minimum of C underscore customer key and maximum of C underscore customer key. Let's run this query. Okay, 1 lakh 50. So minimum is this one and maximum is 1 lakh 50. Let's go to the query history. Okay, so open this query. Go to query profile. See here, it did not scan anything again. Meaning that, see here, it is also saying here metadata based result because this is picked from the metadata. If it is not scanning anything here, it will also say from where it is picking the data. So let's go to other queries if it says or not. So this select star, I said this requires a warehouse and this requires a compute power. Let's see here. This did not use because we have already run that limit 10 earlier in today's session itself. That's why it has used result cache. Let's go to the other queries. Okay, count of star also. This is not, this doesn't require any compute. It will be taken from the metadata. Okay, see here it is metadata based result. Only in the first time it will do scanning and all of that. Let's see. This is the first time we have run the limit query. See here, it has scanned it from the remote disk. It has scanned 33%, and this is the amount of data scanned. There are total 3 partitions, out of which only 1 partition is scanned. If it is really hitting the data, the query plan or the query profile will be like this. Otherwise, it will say just the metadata cache or the result cache or something like that. Okay, so that's about the cache. So store the metadata. Metadata means count, min, max, average, any aggregations. Not any aggregations, only this average, min, max, this information about the table. And when we query the information, it doesn't hit the table and does not require compute warehouse or the virtual warehouse. It doesn't require a warehouse for running these queries, which uses the metadata. The select count of star or minimum or maximum of values, it doesn't require a warehouse. Okay, that's about the types of cache. Now let's see what failsafe. This is a very small concept, I can say theoretically. We have discussed time travel, right? We have a time travel of 90 days, maximum 90 days. Time travel is max 90 days. So let's say you have already passed the time travel. 90 days is already, you have defined a time travel of 90 days on your table and 90 days is already passed. And you still want to retrieve the data. Okay. There will be a buffer time period of 7 days within which you need to contact the Snowflake team. They'll be able to help us to retrieve your data. Okay. So, but this is not ideally how we use the failsafe. Failsafe is meant for some adverse situations due to some server breakdown, or some other issues which are natural calamities. Let's say we have a floods or an earthquake. The data centers might get corrupted and your account might be lost or your data might be lost. In those cases, we will have a time period of 7 days to retrieve the data back. Generally, people say it as after the expiry of time travel, there will be a buffer time of 7 days in which we retrieve the data. But that is not the scenario where we use fail-safe. Okay, fail-safe is not the scenario after the expiry of the time travel that is used in adverse situations. Let's see, most of the times we will get confused with that. Okay, is a 7 day non-configurable mandatory data recovery service that acts as the final safety net for permanent tables starting after the time travel retention ends. So if we have the retention period, you can access that by yourself. But due to some reasons, after the expiry of the time travel, if you still want to get the data because of various reasons, might be this is critical data and you have passed the expiry. That is one case, but that is not ideally how failsafe is used. Okay. See here, purpose. Only for emergency disaster recovery, severe data corruption, accidental drop of critical data after the time travel expires. This is only for emergency purposes, not for the normal use cases. Okay, 7 days following the end of the time travel. Okay, users cannot clone or we will be writing the time travel queries, right? Time travel, sorry, self start from table at or before some timestamp. So this 7 days of buffer time we cannot get it through time travel. Okay, that's what users cannot query, clone, or recover data in failsafe directly. Recovery is initiated by the Snowflake support. Yes. So they might ask you in the interviews what is failsafe. So after the expiry of the time travel of 90 days, in emergency situations or in critical data scenarios, if we want to retrieve the data back, we will have a buffer period of 7 days. Uh, we can contact the Snowflake support team and they will help us to retrieve the data. That is the meaning of failsafe. Okay, the safety period after the time travel basically. So, and data security. Data security, there is something called masking policies. Let's see. Okay, one way of security is through the role-based access control. RBAC, shortly called as RBAC. So we have already seen how RBAC works, role-based access works. So that is at access level. Let's say you have some data, the customer data having some sensitive information. Okay, like his phone number or the Aadhaar number. You don't want to expose that to everybody. Only the admins can see the data, all other users they should see only the masked data. When I say masked data, maybe the last 4 digits or first 4 digits, like that. Okay, for that we need to create masking policies. Let's write here. This is one of the security masking policy uh, for PII information. PII means personal identifiable information. Personal identifiable information. Generally, we should not expose personal identity information. Okay, identifiable or identity, you can call it anything, not a problem. Personal identity information. So we might be dealing with the banking customers or we might be dealing with the hospital patients, whatever it is, we should not expose their personal details to anybody except the admins because admins they will have some agreements to not misuse the data. Okay, so we are restricted to show this data. Let's create a table, customer table. Uh, let's see, we already have a customers table in our database. Select star from customers. I'll add some more columns to this. Okay, right now we have name and ID. Let's create a new table. Create table. We'll say bank customers. Okay, they will have ID, the account ID. Okay, account ID as, let's go with the normal ID is integer. This is like a primary key. Assume that this is a primary key. Customer ID, customer name is varchar. I want to allow 50 characters in the name, and then account number. This should be, let us say, 16 digit or 12 digit account number. Okay, phone number is 10 digits. Let's make it a varchar of 10 digits. And then what else we will have? Let's say this person is also having a credit card. So credit card number. This is of 16 characters, let's say. Okay, all this is a sensitive information except the ID and the name. We should not expose any other details. Maybe we can expose account number, but not the phone number or the credit card number. Okay, these are very sensitive information. So let's insert some data into this. I'm doing everything with the account admin here. Insert into bank customers values. Let's try to insert it. ID 1, name, account number. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. How many digits account number? 12 digits. This is 10, 11, 12. Okay, 12 digit account number and phone number. Let's say this is 10 digit phone number. So if it is a varchar, you should enclose that in the single quotes. Phone number and credit card number should be 16 digits. Let's say this is 16 digits, but in between I will have hyphens. Let's copy this number. Okay, no, I'll create a new number. 4, 5, 6, 7, 1, 2, 3, 4. Okay, now this is how many digits? 12, 13, 14. Now only two more numbers, I think. Let's make it how many characters long? Okay, let it be this much. 12, 13, 14. 14 characters long. Let it be. Okay, this would be the credit card number. Let's insert for few more customers. Okay, let's make ID number. Change the ID numbers. 2, 3, 4. Let's take the names. Okay, let's change the customer numbers. Sorry, account numbers. I'm just changing one or two digits. That's fine. Okay, phone number also I'll be changing one or two digits here and there. This number also. Okay, let's insert this data. Okay, data is inserted. Let's query this table. So let's start from bank. Okay, so this is the information, but now what I want to do is I don't want to expose account number, phone number, and the credit card number. Maybe I can show the last four digits or the first four digits like that. Let's say in all of this, I want to show the last three digits. Okay. In all of this, I want to show last three digits, or else in the phone number, I want to show last four digits. Uh, okay, let's maintain the last four digits in every case. Okay, so if it is account admin, they should see the actual data. Otherwise, they should see only the masked data. So for that, we need to create a policy. Create masking policy. The name of the policy is mask PII, personal identity information, as it. This is the syntax. It should accept a value. It should accept an input that is of type string, and it should return some output that is also of type string. Returns string. This is the syntax. Okay. So we are creating a masking policy with the name mask PII, as it should accept some parameter that is of type string, and it should also return some output that is also of type string. It is like a function we are passing. You remember Python functions? We will be passing the values to that, and it should return something. So here we are passing a value and it is returning the output as a string. Okay. So what I want to do, if it is a account admin, then I want to show the actual value. Okay. Case 1, current role in account admin. Then I should show the value. Whatever is the input, I should show the same value. Else, if it is not account admin, let's say what I want to show. Let's say I want to just to show stars. I'll get that last four characters first, four characters later. Okay. Else that end. There is a spelling mistake. First, let's try to see how we can show only the last four digits or first four digits. Let's write select account number from the bank customers table, bank customers. Okay, here I want to replace for all of these characters with the stars except the last four. Okay, so let's say there are various ways in which you can do this. Okay, so replace, or let's do one thing, concat of stars. How many stars we need? This is 12-digit account number. So first 8 digits should be stars. 1, 2, 3, 4, 5, 6, 7, 8. Followed by right of, right means the right values, the right side values, account number, comma 4. So this right of account number, comma 4 gives the last values, last right 4 values from, sorry, from is already available here. Let's make this here. Okay, let's run this. Concat of as masked. Syntax error at from.
From is two times.
Oh, sorry. Okay, so here now it is showing only the last four digits. So like this, you can mask it. So else I want to show it like this. Else here instead of account number, we should provide value. Okay, so let's create this masking policy. Let's make this, take this here. Okay, create the masking policy. Spelling mistake. Okay, now the policy is created. But we did not attach it to any table or any column. So now let's try to attach it to the customers table and all the PII columns. So in order to attach the policy, alter table, the table name, modify column, let's say account number, account number, set masking policy, and the name of the policy. Okay, let's run this. Statement successfully executed. Let's see. Now I'm in account admin. So first of all, let us see the current role. You can see the role from here, or if you are running through some programmatic access, you have to do it like this. Select current role. Okay, if it is account admin, it will give the actual data. Otherwise, it will give the masked data. Let's say select star from bank customers. Okay, it is showing the actual data. Now let's switch the role. Use role. The role. So let's do select star from customers again. Sorry, I did not execute this. Okay, now the role is changed here. Now let's do select star from customers. See here now the account number, you are not able to see the full data. You are able to see only the last four digits. Let's say I'll also apply the masking policy to phone number and the credit card number. Modify column phone number. Let's execute it. And also apply the same to credit card number. Okay. Now I have applied all the policies. Sorry, policies to all the columns. I'm using the role account admin. Let's switch to account admin. Now you are already in account admin. If you see the data, you will be able to see the complete data. But if you switch the role to DE role, now you will be able to see only the masked data. Okay. So even for your banking messages, they might be showing only the last four digits of your credit card numbers or your account numbers, right? When you get a message, your account is credited or debited, they will show only the last four digits. Okay, this is about the masking policies. Any doubts in the masking policy? So if you want to have a different scenario, like if it is 12 digit, you should show only last four digits. If it is some other length, you want to show only last two digits or one digit, you can make that case statements here. Okay, first of all, decide what do you want. So based on that, you can write this logic and put it here. That's all. And attach the policies. So if you want any other roles to be included here, you can include it. So that's about the masking policy. And then semi-structured. This requires an external table, or yeah, this definitely requires an external table. I'll show that once our account is ready. I mean, AWS and Snowflake is integrated. I'll definitely try to do it. Sorry about that. Previously it was working, but not sure. There might be some changes in the authorization and the integration. I'll need to check. So apart from that, we are only left with that external data loading. Apart from that, let's see, we have something called dashboards. Uh, okay, let's click on create. Okay, go to this database explorer, database and schema. Create interactive table, dashboard. Where is that feature, dashboard feature? Okay, here it is, dashboards. So these dashboards are not, these are not the visual dashboards. It is about the data. Let's say you have some pre-calculated results, or you want to see some data in the table on a daily basis. So for that, you can write the queries here. Let's say I'll create a dashboard. Why is it not enabled? Let's see. I'm an account admin. Why is this disabled? Use dashboards to create and share beautiful interactive visualizations of your data. Yes. Okay. Everything is behaving strange with this account. Why this feature is not enabled? See, 1 second. Let's give it a try. Refresh the URLs. Dashboards. Oh, it's not working. So here, okay, here also we have an option. Okay, from here also we can create a dashboard overview of load sample data from AWS S3 with SQL, analyze sentiment in unstructured data, overview of Spark data frames, introduction to data transformations, show data from Amazon AWS. Previously there is a flexibility to create dashboards directly using the SQL queries. Now it seems to be updated. Let's try with this. But this also needs external integration. Let's open the worksheet. Let's see what they have written. This is a template. And okay, this also requires the external stage. Okay, let's get the S3 account created and I will continue on this. Okay, so I'll stop it here for today. Sorry about that external stage. Okay, I'll share this file. That's the only concept left in Snowflake. Otherwise, we will start Azure.
Still, what all concepts are pending? Can I know?
Mm, yeah, the Azure Cloud, Data Lake, ADF, and Databricks and PySpark. These are the
Okay.
concepts left. Okay, I have shared the file in the chat window. Please download that and let me know if you have any questions apart from the external stage.